This is section 10.6. We'll look at partial pressures. So if you have a container and it has more than one type of gas in it, the mixture of those gases is going to give you the total pressure inside of the container. We can write a mathematical equation showing this. Since I wrote nitrogen gas particles in here and hydrogen gas particles in here, the total pressure inside of the container would equal the partial pressure of nitrogen and the part of the pressure that is hydrogen. These are called partial pressures, and the addition of all the partial pressures that make up a particular gas give you the total. A sample of our atmosphere is a good example of that. We have oxygen, nitrogen, a little bit of helium, maybe a few other gases, and each pressure that comes from the individual gases gives us our total atmospheric pressure. In the laboratory, many times we'll see a process where we collect a gas over water. I have a picture of that here for you. This is an example of an experiment where a substance is heated and then it produces a gas, in this case oxygen gas. A bottle is tipped over inside of a tub of water. This tube right here has gas that bubbles into the container, and it fills the container and forces the water back out of the container. Here's an actual full bottle right here after the oxygen gas completely bubbled in and removed the water. The problem is that this gas right up here is not just pure oxygen. This gas is also some water gas that's dissolved in it. And so if you want to draw your own picture of it, it could look like this, where here's a container that's tipped over inside of a tank of water, and the gas is added to this tank, the water is forced out, and then the gas starts to fill this container. This gas right here is not just the oxygen gas or whatever type of gas you're trying to collect. It also contains evaporated water, also known as water vapor. And so the total pressure inside of this container, or inside the gaseous part of this container, is equal to the gas you collected's pressure plus the water gas's pressure, known as the water vapor's pressure. There are actually tables of water vapor's pressure because water is very well known for its evaporative ability, and it only depends on the temperature that the water happens to be at. And so there are water vapor pressure tables based on the temperature of the water that exists. When we do a laboratory activity like this, you'll need to look up that water vapor's pressure based on the temperature of the water that's being displaced by the gas that's going into it. So this is an application of what's called Dalton's law of partial pressures. Dalton's law of partial pressures simply states the same thing that we just stated. The total pressure inside of any system is equal to the parts of the gases that make that system.